Okay, hello everyone. So I'm gonna go over lesson 8.4 today. And this is pretty much a continuation of the lesson that we did in 8.3. We learned about SOHCAHTOA, which is just an acronym that helps us remember the different trig ratios. We have sine, cosine, and tangent. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And then tangent is equal to opposite over adjacent. So we're going to still use these today because we're going to learn about inverse trig ratios, which is basically the opposite of what we did in 8.3. In 8.3, we were starting with a side length and an angle, and we could use that to find a missing side length. In this lesson, we'll be starting with two side lengths, and we're going to use those to find a missing angle. And so it's pretty much the same type of math. It's just going to be a little bit different setup when we started off. Like with number 1, it says find the value of x, round to the nearest tenth. So we would still kind of follow that same process. Highlight or circle your angle, and then figure out which type of sides do you have. Well, the 15 is going to be an opposite leg, and then the 24, because it's across from the hypotenuse, makes it, across from the right angle, it makes it the hypotenuse. So I have opposite hypotenuse, which means that I'm going to use sine. So let's go ahead and write sine, and I don't know my angle measure, so I'll just write x. And that is equal to opposite over hypotenuse. Well, my opposite is 15, and my hypotenuse is 24. So what I have to do now to undo the sign that's going on with the x, I can't just divide by sign like we might in the past, because that wouldn't work out. What I need to do is take the inverse sign, and so that's how we're going to solve for x. So x is equal to, and the way that we write inverse sine is just sine and then put a little -1 at the top, and that doesn't mean much except it just means inverse sine. And then you put your 15 over 24 in that. And so to know what the answer is, you just go to your calculator. Basically the sine button, or any of the trig ratios, once you press second and that button, so in this case we would press second and then sine, that is going to be how you get your inverse sine. So you press second inverse, or second sine, and then in the parentheses you just type 15 divided by 24, and that's going to give you your answer. As long as you're in degree mode, you'll get the right answer. Make sure you're not in radians. So let's go ahead and write this answer. This one comes out to 38.7 degrees. Okay, let's look at number 2. I'm going to start by highlighting my angle and figure out which types of sides I'm working with. This side that's 8 is a leg, and because it's touching my angle, that's an adjacent leg. The side that's across from the right angle, that's the hypotenuse. So because I have adjacent and hypotenuse, I need to use cosine. So let's say cosine of x is equal to 8 over 11. And then to find x, all I have to do is take the inverse cosine of 8 over 11. So you just type that into your calculator, and whatever comes out is your answer. Just round it to one spot after the decimal. So that's 43.3 degrees. Okay, let's look at 3. So I have my angle, I have an opposite leg, and I also have an adjacent leg. So because I have opposite and adjacent, I'm going to use tangent. So we decided that we're going to use tangent. So let's write tan of x is equal to, and my ratio is opposite over adjacent, so I'm going to do 20 over 37. Now to find x, all I have to do is take the inverse tangent of 20 over 37. So when I type that into my calculator, I end up with a decimal 28.4 degrees. So because we're finding angles, all of these should have a little degree symbol at the end. So let's look at number 4. Our angle here is touching this 18, and that's a leg, so that's the adjacent leg. And then the 23 is across from the right angle, so that makes it the hypotenuse. So because I have adjacent and hypotenuse, I'm going to choose cosine, and then I'll just say cosine of x is equal to 18 over 23. So to find x, I just have to use inverse cosine. Inverse cosine of 18 over 23, just type that into your calculator, and it's going to come out to be 38.5 degrees. Okay, and then number 5 is going to be pretty similar. I have a hypotenuse, and I also have an opposite. So I'm going to use sine this time. Sine of x is equal to 40 over 41. So x is equal to inverse sine of 40 over 41. When I type inverse sine of 40 over 41 in the calculator, I'll get 77.3 degrees. And then number 6. So this one, I have to figure out what type of legs, this is going to be the opposite leg, and this is the adjacent leg. So I have opposite and adjacent, which means I'm going to use tan. So tangent of x is equal to 7 over 5. So x would be whatever the inverse tangent is of 7 over 5. So x is equal to, this comes out to 54.5 degrees. Okay, so knowing how to do these problems is really important because this is trigonometry. This is the point of the whole unit, and so it might be a little bit difficult, but I want to give you guys a lot of opportunities to practice so that you can do really well on the exit tickets and on any tests that you may take. So let's go ahead and review a little bit of what we did in 8.3. So this is going back to where we have an angle measure, a side length, and we're trying to find a missing side length. So let's identify what type of sides we have. This is a opposite leg, and then the x side is an adjacent leg. So because I have opposite and adjacent, I'm going to use tan. After that goes our angle measure, and this time we know what that is. It's 39. So I'm going to say tangent of 39 is equal to 11 over x. And then I can cross multiply to get my answer. So x times tangent of 39 is equal to 11. And then I just divide by tangent of 39. So x is equal to, and then I just go to my calculator and type this in. 11 divided by tangent of 39 comes out to 13.6. So that side on the bottom, our adjacent leg, measures 13.6. Number 8, I need to figure out what I'm working with. I have a hypotenuse because this is across from my right angle. And then I have a leg. Because it's right next to my angle, that makes it the adjacent leg. So I am going to go ahead and use cosine here. And after that goes my angle measure. I don't know my adjacent, so I'm just going to put x. And my hypotenuse is 28. So now I'm going to cross multiply. X is equal to 28 times cosine of 46. So you just type that into your calculator and it'll give you your answer. In this case, it's going to be 19.5. All right, number 9. I can tell that I'm working with both of the legs. This is an opposite leg, and this is an adjacent leg. So I'm going to go ahead and use tan again. Tangent of 51 is equal to opposite over adjacent, so 8 over x. And then I cross multiply. X times tangent of 51 is equal to 8. Then I take tangent of 51 and divide that. So 8 divided by tangent of 51 is going to be 6.5. And because we're finding side lengths right now, we don't need to put the degree symbol after it. You only need the degree symbol if you're finding a missing angle. So let's look at number 10. I can tell that I have a hypotenuse here. This 31 is across from the right angle, and then the x would make that the opposite leg since it's across from my angle. So if I have opposite and hypotenuse, I'm going to use sine. And then I can say sine of 24 is equal to x over 31. So x is just going to be equal to 31 times sine of 24. So whatever comes out there is my answer. This is going to be 12.6. So there's pretty much just a lot more review of this, and I'll walk through these because they might mix it up. They might try to make it a little bit more complicated, like we're going to see later on in the video. So this one, let's see. I'm going to start by writing SOHCAHTOA at the top just so that we start to remember this. I can tell I have a hypotenuse, and this leg is my adjacent leg. So that means let's use cosine of x is equal to 14 over 22. Because I'm trying to find my missing angle now, I have to use inverse cosine. We only use inverse cosine when we need to find a missing angle. So go ahead and type that in, inverse cosine of 14 over 22. That comes out to 50.5 degrees, and so that's the answer. Number 11 is one of these that I have to find a missing angle again, so that means I'm going to use one of the inverse trig functions. I can see I have an opposite leg, and I also have an adjacent leg. If I have opposite and adjacent, I'm going to use tan, so tangent of x is equal to, and it's going to be 25 over 78, because I want opposite over adjacent. So x is equal to the inverse tangent of 25 divided by 78. So whatever the inverse tangent of 25 over 78 comes out to be, that's our answer. It's going to be 17.8 degrees. Number 13 is another missing angle one. So let's try and figure out which trig function we're going to use. This looks like a leg to me, so this is the adjacent leg because it's right next to our angle. And then the 36 is across from my right angle, which makes it the hypotenuse. So because I have adjacent and hypotenuse, I'm going to use cosine. I don't know my angle measure, so I'll put x. And then I want to do 31 over 36. So to find my x, I need to use the inverse cosine function. So 36 goes in the parentheses. And whatever the inverse cosine of 31 over 36, that's my answer. So this comes out to 30.6 degrees. And let's do one more of these simple ones. I can see that I'm working with a leg that's across from my angle. That makes it the opposite one. And then the 19 is across from the right angle. So that makes it the hypotenuse. If I have opposite and hypotenuse, I'm going to use sine. I don't know the angle measure, so I'll just put sine of x is equal to 10 over 19 because it's opposite over hypotenuse. So x would just be the inverse sine of 10 over 19. And the inverse sine of 10 over 19 comes out to 31.8 degrees. So let's look at 15. They do start to show like multiple triangles combined so that we have to do multiple steps. We want to find DE, which is this side over here. And we only know this angle measure. We don't know any of the side lengths. So it might be helpful if we knew what this side length was, because then we could use that and the 19 degrees to figure out what DE is. I'm going to call this X. The side in the middle, I can call that Y, and then use the 61 degrees and the 24 to find out what Y is. So because I have an opposite leg and an adjacent leg, I'm going to use tangent. Opposite and adjacent is tan. So tangent of 61 is equal to, I'm going to put y over 24. And then I solve this, so y is equal to whatever 24 times tangent of 61 is. So 24 times tangent of 61 comes out to 43.3. So I can fill that in here now. 43.3. And now I can figure out what I'm working with. So this is a leg of my bottom triangle as well, and it's the adjacent leg. And then the side that I labeled as x, that's the opposite leg. So I'm going to use tangent again because I still have opposite and adjacent. But now instead of 61 degrees, I'm going to write the 19 degrees. So tangent of 19 is equal to opposite over adjacent. So this is going to be x over 43.3 because that 43.3 is my adjacent. So let's go ahead and solve this. X is equal to 43.3 times tangent of 19. So when I put that in my calculator, I'm going to get 14.9. And that's my x, which also is the length of DE. So let's just put equals DE. So this is our answer. Number 16 is asking us to find an angle measure. It wants to know what is the angle measure of angle W. And remember, if we want to find a missing angle, we have to use the inverse trig functions. So let's see what we can start to find with what I see on the right. Like in this triangle, I have an angle measure, that 25 degrees. I have a side, the 15, and it would help if I knew one of the sides that was on the other triangle, which would be this one. So that side is the hypotenuse of my triangle on the right, and it's going to be a leg of the other triangle. So let's go ahead and use a variable here. I'll just call this x. And basically, I have opposite and hypotenuse, so I'm going to use sine. Sine of 25 is equal to 15 over x. Then let's solve this. I'm going to have x times sine of 25 is equal to 15. Then to find x, I divide by sine of 25. X is equal to 15 divided by sine of 25 comes out to 35.5. Okay, so let me fill that in. I know that this is 35.5. I know the bottom side down here is 22. So let's see which one we're going to have to use. This turns out to be an opposite leg, and this turns out to be an adjacent leg. If I have opposite and adjacent, I'm going to use tan. I don't know that angle measure. I'm going to call this y. So tangent of y is equal to, and it's opposite over adjacent, so I'll put 35.5 over 22. And then to find y, I just need to use inverse tangent of 35.5 over 22. So y is just equal to 58.2. And we're talking about the angle measures, the measure of angle W. So this is our answer, 58.2 degrees. And then, of course, we are going to do some word problems where we basically just have to draw our own picture, but it should be the same type of math. Number 17 says a ladder leaning against a wall makes an angle of 75 degrees with the ground. If the foot of the ladder is 6 feet from the base of the wall, what is the length of the ladder? So let's try and draw a picture. I know that there's a ladder leaning against a wall. So here's my wall and here's my ladder. And it makes an angle of 75 degrees with the ground. So this angle is 75 degrees. The foot of the ladder right here is 6 feet from the base of the wall. So to here, this is 6 feet. The question is, what is the length of the ladder? So basically, I want to know this. Let's draw in a right angle here. And now this should look pretty similar to what we've done so far. This 75 degrees makes this 6 an adjacent leg, And then the ladder is my hypotenuse. So because I have adjacent and hypotenuse, I'm going to use cosine. I can say cosine of 75 is equal to 6 over x. Then I just need to solve this. So x times cosine of 75 is equal to 6. To find my x, I just need to divide both sides by cosine of 75. So whatever 6 divided by cosine of 75 is, that's my answer. It comes out to 23.2. And don't forget to include your units or measurements. We are talking in terms of feet in this problem, so just include that. Number 18, Jaden is flying a kite and lets off 275 feet of string. If the kite is 150 feet above ground and assuming the string is straight, what angle does the string make with the ground? So let's draw like our string. The ground and the string makes the kite go all the way up here, and that is 275. The kite is 150 feet above the ground, and we want to know what angle does the string make with the ground. So this is the angle that we're looking for. So let's go ahead and use one of the inverse trig functions here. This is an opposite leg, and this 275 is our hypotenuse. So because we have opposite and hypotenuse, we are going to use sine. So let's do sine of x is equal to 150 over 275. To find x, I need to use inverse sine. So the inverse sine of 150 over 275 is equal to 33.1, and because it's an angle measure, I'm going to put the degree symbol there. And that's my answer there. So that should be enough information to get you through the lesson. If you need any help on the next page, just let me know. They're basically just examples of each of the different types of problems. And go ahead and make sure that you have the exit ticket completed and homework for 8.4.